Hello, my darlings. We are now going to be looking at different segments in circles, so chords and then two intersecting chords. So this one starts with congruent corresponding arcs theorem, which basically says in the same circle or in congruent circles, if the chords are congruent, then the intercepted arcs are congruent, and vice versa. So as you can see here, these two chords are the same length, and then these two arcs are the same length, and these two circles are congruent to each other. So since these chords are the same, then these arcs are all the same. So looking at this diagram here for example 1, notice the radii are the same. If the radii are the same, then the circles have to be congruent to each other. Okay, so we were given circle P is congruent to circle Q, and chord FG is congruent to chord JK. And then we have the measure of arc JK is 120 degrees, so the measure of arc FG is also 120 degrees. Okay. So example 2, same concept, congruent circles, congruent chords. So if arc JK is 80 degrees, then arc FG is also 80 degrees. All right, the next theorem is the perpendicular bisector chord theorem, which basically says if the diameter is perpendicular to a chord, then it's going to bisect the chord and the arc. And if a segment is a perpendicular bisector to a chord, then that segment must be the diameter. But the main thing here is diameter perpendicular to the chord, it bisects the chord, and it bisects the arc. So looking at this picture down here, we know that arc HJ is going to be congruent to arc JK because the diameter is perpendicular to the chord. So we can set those equal to each other. So subtract x, divide by 10, and x equals 7. And oops, that was part B. So then find the measure of arc HK. So that's the entire thing. So I plug that into both of those and add them up together and get 154 degrees. Sorry, the easier part is HK. Well, if the diameter bisects the chord, if this piece is 7, this piece is also 7, so 7 plus 7 is 14. And same concept over here. The diameter is perpendicular to the chord, so it's going to bisect it. So if this is 14, this is 14, which means the entire segment is 28. And the arcs are also congruent, so 2x minus 8 equals 127 minus x. So add the x, add the 8, divide by 3, x equals 45. But then we wanted the measure of HLK. So HLK goes around this direction. So first I found these were both 82 degrees. And then subtracted those from 360 to find the arc we wanted is 196 degrees. All right, so those are chords in a circle. And this is another way we look at chords in a circle is if we have two chords that are intersecting. And I know I'm not in class with you to do this part with you, so we were going to draw two chords and just find their measurements and hopefully find out what this theorem tells us. Is that if two chords intersect in the interior of a circle, then they cut each other proportionately. So meaning here's one chord, and I said this part is A and this part is B, and here's the other chord, and this part is C, and this part is D. A times B equals C times D. So looking at example 1, going this chord, I get 8 times X. Going across chord PR, I get 6 times 4, and they're equal to each other. So 8x equals 24, and x equals 3. So here, we want to solve for ML and JK, but before I do that, I need to solve for x. So going across chord KJ, the first part times the second part, so x times x plus 4, equals, and now going across the other chord, the first part times the second part, x plus 1 times x plus 2. So on the left side, I distributed my x. X times x is x squared. X times 4 is 4x. On the right side, I had to distribute the x, which gives me x squared plus 2x. And I have to distribute the 1, which gives me plus x plus 2. So 2x plus x is 3x. I subtracted x squared from both sides, so those are now gone. And then I subtracted 3x from both sides and got x equals 2. But it didn't ask for x, it asked for the lengths of the chords. So if I plug the 2 in, this is a 2, this is a 6, so the entire chord is 8. And then if I plug a 2 in here, it's 3. If I plug a 2 in here, it's 4. So adding those together, the entire chord is 7. And finally, example 3. 2 students are trying to set up an equation to solve for x. Who is correct? So we have 2 chords intersecting in a circle. So x and 3, 4 and 6. And Monique says it's 3 plus x times equals 4 plus 6. Stacy says it's 3 times x equals 4 times 6. Well, they cut each other proportionally, so that means we're going to be multiplying. So Stacy is correct, and we need to let Monique know that you need to multiply, not add. And that's it for our segment in circles, and that's the last set of notes for this unit.